All right, so we're going to look at this problem here. So I'll have a read of it and then give it a go, and then we'll step through it. So find the value of D such that the shaded regions, so it's just the shaded areas rather, are equal. So we need this grey area to be equal to this green area underneath. All we know is that we've got this function f of x, which is x squared on 1,000 multiplied by 50 minus x. And we've got this linear line going through it, goes through the point 10, 4, and it goes through some other point that's at D, and therefore the y-coordinate at that point is just f of D. And basically we need to change this value of D such that those areas are the same. We can sort of eyeball it a little bit here. It's around 40 something, but we need to work it out exactly. Now I actually think this question is not correct. It's not asking, well, you can understand this concept much more easily than with this problem. I think I don't think the question's well designed to teach what it's trying to get across. But anyway, let's jump into it. Here's the solution. Pause and have a bit of an understanding of what's going on, but let me talk through it. Basically, we need to know the equation of this pink line. That's the first thing we need to know. So the way we're going to do that is that we're going to know that it's linear line. So we know that this function that we're going to call g of x has the equation mx plus c. Okay, the gradient, so I'm just going to leave things in this form because otherwise if you substitute things in, it's just going to be messy. But the gradient is just rise over run, so that's f of d minus 4 divided by d minus 10 multiplied by x plus the y-intercept, which is c, which we don't know. But we can work out c. What we can do to work out c is we substitute in this coordinate 10, 4 into this equation. So when g of x is equal to 4, when g of x is equal to 4, the x value is 10. So if you substitute that into there, so g of x being 4, x being 10, and then rearrange for c, you're basically going to get 4 minus 10 groups of this fraction. So that's 10 f of d minus 40 on d minus 10. As I said, f of d is just d substituted in here, this unknown parameter we don't know. Anyway, you get this messy thing, which is your linear line. That's just a linear line in some other parameter d. In any case, the sort of nuts and bolts of the question is this: how do we make those areas equal one another? This is where you need a CAS, and it's actually one of the few times where a CAS is better than a computer, because you need to basically solve this for d. So let me explain. So taking the integral from 10 to d of f of x minus g of x. Remember, f of x is the upper function, g of x is the lower function, so that tells us this grey area. And we need that grey area, or that top area, to be equal to, and this is where it's tricky, there's actually 3 integrals here. You've got 3 sections here, because you've got this part here, which is the integral from 0 to 10 of f of x dx. Just calculating that definite integral there. And then you've got this integral, which is sort of in the middle. It's kind of like a trapezium, which is the integral from 10 up to this point D of g of x, which is obviously the pink line. And then you've got this little slither here, which is from d to 50 of f of x dx. And I guarantee you, if you whack that in your CAS and then as a solve, and then write comma d, you'll get an answer of, drumroll, 45.8816. So if we take this, and we have to actually be really, so we have to go to a lot of decimal places to make sure it's exact, 45.881603 and so on. That'll be good enough. You can see that that value gives us the areas equal to one another. That's a particularly tricky example. As I said, I think the question's not really designed that well. But then again, there may be an easier way to do that I didn't think about. So if you've got any better ideas on how we can solve that problem more efficiently, I am all ears. But I think, there's better questions you can do that get the same idea across, if that makes sense. So good luck with all your studies. I'll talk to you soon.